Alright, so yesterday we looked at graphing to find limits, and then we looked at direct substitution to find limits. Today we're going to look at dividing out to find limits, and then we're going to look at what a one-sided limit is. Alright, so if I look then at example 1a, I'm given the limit of x squared plus x minus 6 all over x plus 3, and I want to find that limit as x approaches negative 3. And I know that I can't do direct substitution because of my denominator. If I plug in negative 3 to my denominator, negative 3 plus 3 is 0, and you can't divide by 0. So that's why I know direct substitution won't work. And so I'm going to try to factor my numerator and see if I can get that x plus 3 to cancel. Yep, so factors of 6 that subtract to 1 are 3 and 1. No, 3 and 2, sorry. So x plus 3 and x minus 2 is how that top factors. Okay. There you go, so you cancel your x plus 3 and you're given x minus 2, so the limit as x approaches negative 3 of x minus 2. Then you plug in your minus 3, so negative 3 minus 2, which is negative 5.
So
basically it's like factoring, yep. Okay, so if I'm given the limit as x approaches 2 of x squared plus 2x minus 8 over x minus 2, because if I plug in my denominator, I get 0, then I need to factor that out to cancel the x minus 2. So factors of 8 that subtract to 2 are 4 minus 2. So x plus 4 and x minus 2. And then can cancel my x minus 2. So I'm given the limit as x approaches 2 of x plus 4.
2 plus 4.
Yep, and if I plug in my 2, 2 plus 4, 2 plus 4 is 6. Does that make sense? We want to do one more. Makes sense? Okay. Then the other thing we're going to look at today then is one-sided limits. So limits either approaching from the left or from the right. And this happens when you graph something and your graphs don't come together. So I'm given the limit as x approaches 0 from my negative side. So anytime it's from a negative, you're looking at it from the left. So you're going this direction. Or as x approaches 0 from the positive side, which is from the right. So you're looking at it from this direction. And so in order to find that limit, we're going to have to graph. So you're going to need to graph the absolute value of 2x divided by x. Okay, so if I go to my y equals screen, given y equals, if I want to find my absolute value, I go to math and then number, ABS. 2x divided by x. Okay, and then you graph it. And we get a graph that has 2 different pieces, which is why we have to look at the limit in 2 different ways. So if I look at my limit as I'm approaching from my negative side of 0, what y value am I at from the left? Negative 2. Okay, and then if I go back and look at my limit as I'm approaching from my positive side from the right, then I get positive 2. So that's why you have to look at those limits in 2 different ways. Okay, so we'll do one more of those, and then you guys can get started. So the limit as x approaches 0 from my negative direction, so from the left. And the limit as x approaches 0 from the positive direction, so from the right. Go away. Alright, so if we graph this, x divided by the absolute value of 4x and I get kind of a graph where it's kind of hard to tell where those values are at. So if I go,
How do you put it? 0 for x?
no,
Why do you put x have absolute value?
oh, yep, that's why it looks kind of weird. Alright, we'll try again.
Yeah, like weird things for us.
Do you? Okay. Oh, that looks so much better. Okay, so the absolute value as x approaches 0 from the left, what do I get? 0, and from the right, 0. Okay, so that's what you guys are going to be working on. You're going to be working on dividing out on 913, and then graphing one-sided limits on 55 through 62.